So anyway, research data management challenges. Well, this is the sort of the obvious one. This is probably how you're all feeling a little bit after lunch. The dog ate my research data. There's some horrific photos on various research data management websites. Have you seen this rucksack? It's got my thesis in it. This sort of thing. The fantastic stories of memory sticks, all with nice little printed labels on, but they didn't actually realise that that these things degrade, and so do the labels. So they've got a cabinet full of, not at Bristol, I hasten to add, cabinet full of memory sticks. Nobody knows what's on any of them. So there's some basic sort of looking after the data, and a lot of this is around keeping things secure, stopping people getting at data. This is the sort of history of research data. It's putting it somewhere safe, making sure we don't lose it, making sure that our competing researchers don't get hold of it. This is the sort of historical sort of perspective on research data. So you get these big storage facilities, but the landscape's changed. The landscape's changed for the better, but that's where the challenges start to come in. I'll talk specifically about the sort of facilities we've got at Bristol in a moment, but first up, there's this thing about sharing. So there's a big push. There's a big push from all the research funders saying that you've got to put a data management plan into your research proposals. You have to say how you're going to share your data. And the default assumption is that data will be shared, even in the medical domain, and you have to put some sort of argument in about how you're going to make access to even sensitive data available. Keep in the back of your mind that we've got these systems that were designed to keep people out. And then there's the sort of the pull side of it. The pull side of it is the sort of the journals saying, yeah, we want data citation. If you publish a paper, people reading that should be able to follow a citation and get hold of the data or gain access to the data. At Bristol, as in a number of repositories elsewhere, we've gone down a sort of traffic light, sort of three-level system. So we've got open and freely available, which was the thing we tackled first. Registration required, so some sort of reasonable check of the person requesting it is a bona fide researcher. I'm not entirely sure how you establish that, but anyway, we have a process for that, and we've agreed a process for that within the university. And then controlled access. So this is the first of one of the sort of big challenges around this that actually I'm not going to address in the first part of my talk. So this is research active data. A lot of the rhetoric around research data management has focused on what you could consider to be sort of library kind of static deposits of data, archival data. And here you've got research active data. So this is where people are continuing to grow their research collections, their research data collections, and they want to do things with it. And this is just to give you a sort of spectrum of the range of sorts of things that wouldn't necessarily be a problem that IT was facing historically, that we're increasingly being asked to do. So up the top left there, we've got crowdsourcing mobile applications. Top right, there's a gene references in academic papers, making some research available there. We've got volcano plume modeling that happens on the supercomputer and wanting to get impact. Impact is a sort of big thing as well in research now. So people are wanting to things to actually happen with their data in terms of usage after the actual research project has finished. And of course, this gets considered in the ref as well. So there's money made available by institutions for this and by funders for this. So there's a lot of activity around using data like this, and there's a whole bunch of things around digital image collections, local engagement with the city, and even mining our own researchers within the University of Bristol. A whole load of complicated things there to think about. So, evolution of research data management support at Bristol. So this is the sort of the trick. This is the happy part that worked very well. So I'll tell you what we did really well. CISG, it's probably in my experience one of the best programs CISG have ever run was the research data management program, which is fantastic. They pump primed quite a few of the institutions, I'm sure, that are here to set up some sort of research data service. Bristol was one of those. This was back in the day when CISG logo was all capital letters, and they'd since disappeared for a year and spent lots of money and came back with something that looks very much like a compact disc logo because they made the last three letters lowercase. And then we've got our project here, the sort of data.bris, and sort of as a trailer for something else I'm going to talk to, I thought of a really cheap way we can do big data. If we just change this D here to a big D, we'll follow the CISG example, and then we're doing big data. So this is the University of Bristol's computing facility. This was, I'm telling you the landscape before they had the data.bris project. I might be slightly exaggerating there. That we've closed that one now, haven't we, Luke? I think, yeah. Okay. So what we actually had a really good facility. This was before we started this project. So we spent £2 million on a research data storage facility so that every PI at Bristol has 5 terabytes of store. That size was strategically chosen because it was more at the time, back in 2011, that it's more than you could go to PC World and buy, conveniently. So it was set just bigger than the sort of cheap hard disk sort of level. We're probably going to need to up this now because disk capacity's gone up. But that's why that figure was chosen. And you get that forever, where we define forever as 20 years. And then you can also buy extra storage. So this is a really nice, really nice facility, and it's due to the foresight of Ian Stewart, who heads up the advanced computing unit, that we actually had that already at Bristol when we came to put in the proposal. When we came to put in the proposals to GIST to get this money, we had a research data storage board. I put in brackets the plus management because GIST's call was research data storage and management, so I persuaded the board to change their name and prior to putting in our proposal. But the important thing about this committee is it's an important governance structure. You've got to, echoing the previous speaker, you really have to have in this case the academics from across the university engaged with this before you have all the technical infrastructure and everything. And this was really, we took this as the basis of our project. So we had representatives from every faculty and from all the key support services and other major stakeholders in an existing structure, so we're able to hit the ground running. And we also had a research information system. But essentially what we're giving people was storage, nothing more than that. So in this project, with IT services, we put the proposal in, but in partnership with the library and research services, which initially consisted of a phone call saying, would you like to do a bid? And then developed on from there. But also, importantly, there's a couple of external partners that were making this work across the community. So there's the Digital Curation Centre, which is a mine of useful information about research data management. And then GISC itself, the programme actually brought people together, banged heads together, and got people sharing all their information across the programme. The sorts of activities that are going on without the head banging, although after the dinner last night, maybe. My head was banging this morning. And then in that big circle, the representation of researchers, so drawing on that existing group. So co-design is the real theme from this. It isn't something that came out of IT. Okay, so this is the bit that all went well. Time passes. We set up some principles. We agreed principles because we knew a policy would take too long within an 18-month project to actually get a fully agreed policy. So we set principles up. We got principles saying the university will do this, researchers will do that, postgraduates will do the other. So there was some sort of statement of intent, and then we talked to people. We produced web guidance. We produced guidance. Importantly, this will come back to this in the issue of funding this kind of work. We produced guidance specific to each funder, and this turned out to be particularly popular. We then we finally got to software and systems, and we built a layer over the top of the storage. So it is a very thin software layer over the top of the storage, and as soon as we find something that would do the same job, we quite happily buy something to do this, but at the time we weren't able to find something that we could implement within the timescales. But so we have some bespoke software that does this, that allows researchers to deposit software. And then one of the other things we discovered, as soon as you start to talk about archival research data, people want to talk to you immediately about research active data. So the next thing that sort of came up was collaboration space. So this is sort of Dropbox writ large, but with different levels of security. So we have a facility for sort of sharing links for sort of semi-secure data, but security through obscurity isn't really proper security. But we also have a sort of key-based sharing facility, which is a bit clunky, but it does the job and turned out to be one of the main drivers for bringing researchers in to the service, the actual live collaboration space. And from that, we then got them involved in the actual depositing the archival stuff. So yeah, anyway, we developed business cases, lots of those things. We got these all approved. So this is all the happy stuff, okay? This is all the happy stuff. So the GIST project, 2011, 2013, that all went well. We were delighted we got a business case to money from the university to set up a pilot service, which ran until this year. And so this then moved the service into the library. So we're looking after, within IT, we're looking after the infrastructure part of it and the software systems atop the hardware. But now it's an ongoing service, so we've got to keep it going. And there's some real issues, which we've got some good ideas, and we've started to take a few steps in the right direction for these things. So I'll talk through those, and then just when you think you're getting on top of it all, there's some more issues at the end, which I'll sort of highlight in the closing slides. So sustainable research data management, trends, challenges. What do we mean by sustainability? Well, one of the things we produced actually was a glossary to clarify terminology. In fact, I'd probably change this now because we have more sophisticated access than just publicly accessible. But it's the process of ensuring that digital outputs remain publicly accessible and usable beyond the end of funding. So not just the papers, but the research data. So this is probably the most sort of useful take-home slide of the entire presentation. So if you only want to read one slide, this is the one. It's got no pretty pictures either. So I'll talk through each of these and then go into the last one in a little bit more detail, because it leads into one of the main challenges that's facing us now. So one of the big challenges is that research funding is for a limited period, and the rules of research councils are typically that you have to spend your money within that period. You can't build up reserves to pay for things over several projects and several research grants. You have to spend it within that period. So we basically started out with a subscription model for the extra storage. So everybody gets the 5 terabytes and then additional storage you can pay for. But also there's these sort of systems that we've ended up building around people's research data. It's how do we keep those running? When can we turn those off, please? there's a real danger of creating an expectation that IT will continuously pick up the cost of hosting these things. So the model we've gone for is within research data management. It's known as the Princeton model because everybody copied Princeton, which is pay once, store forever, and it relies on sort of Moore's law, Amdahl's law that today's research data will fit into the corner of tomorrow's research data storage. It entirely relies on that principle. So we'll take some money off you from your research grant now as a researcher, and that will pay for us to look after that data for the 20 years. That's the model, and this has been sort of costed out. We're hoping it's going to pan out. It's working so far, but that's just the storage. That doesn't include curation. Okay, the other thing is actually all these other bits of software, that grow up around this. These are far more difficult. Software doesn't get cheaper to look after as time goes on. Luke's smiling at me because we continuously have this problem that researchers come to us and say, well, we've developed this thing. It's really clever. It's really good. The postdoc's gone now, but we need it. This 12 million grant depends on it. You IT, you have to look after it. And then we have these conversations, and Luke goes, "Isn't that research IT?" And I go, "Oh no, we've got no money for that." And it's trying to avoid that sort of situation ahead of time. So what we've done is we've started a real education process to build up the understanding of this within the research community. And given that IT budgets are pretty much across the board shrinking, that we can't pay for this stuff out of core IT budgets. So how then do we get access to the money to pay for this? And the process here is to actually get things written into grants. So you've got to have the conversation at the time of putting in proposals. So one of the key parts of that is including IT staff, IT specialists within our full economic costing tool. And in fact, my own group, as of February, we become a facility, much like an electron microscope or something that you can actually book at day rate. There's a interactive step. You can't pick your own prices for the software, as has traditionally happened when academics put in research grants. We had a fantastic one with we want several really quite complicated native phone applications for I think it was £6,000. And when given an example costing this, these things can quite easily cost 50, 60,000 plus each for each version. So there's an IT involvement in the actual costing. So the subtext part on that is raising awareness of what's standard and what's non-standard. It damages research proposals to include things that research funders expect to be provided free at the point of use by the institution. This can include sort of trivial static websites, non-branded websites, that sort of thing. It damages your proposal if you ask for money for that. It has to be something that's unique to a grant. So getting that process going has been tremendous. But then, of course, there's an expectation management thing, because this is, you're really opening up the fire hose, because there's an expectation that IT can then meet all these requirements. So we've got a real sort of dynamic, flexible resourcing issue around this, in that we never know quite which grants are going to come off, about 20% of them. And we have to then try and accommodate the start date. So we're looking at being a very smart outsourcer for a lot of these grants that come in, because we can't do them all in-house. And the last thing is leading into one of the sort of upcoming challenges, really, that I'm going to sort of start to wrap up with. So the skills profile of IT is being influenced, the required skills profile is being influenced by the changing landscape. We've heard a lot about things like cloud and the like, but there's an awful lot going on at the moment around big data. It's big data in quotes. It's a very vague term. It's a very vague term. So what we decided to do was to look at the profile of skills that we had to support researchers. This was under guidance from the governance. So let's find out what we do actually already know. So we used something called Bristol Online Surveys. As every talk I ever do has an advert, Bristol Online Surveys, in because it's something we operate out of Bristol. So we put together a Bristol Online survey. We surveyed all our staff. Initially, the unions were quite, this just completely took me by surprise. The unions were quite aggressively anti doing this because it was perceived as being a threat that you were asking everybody what skills they have. But I think once we'd pitched this around, actually, if it's an opportunity to get involved in more interesting work, to emphasize and make use of the skills that you do have, it was much better received. And in fact, we got a very high response rate. So this allows us to ask questions like, which skills do we have the most staff at advanced level? We asked staff to rate their expertise as basic, competent, advanced. It was entirely self-elected grading of expertise. And how does that compare with competent basic? So there's a whole list. What you're seeing on that chart, if you're curious about what the skills are at Bristol, you can actually zoom in on this on the PDF and read them. But there's a whole list of different skills down there. And if you were to zoom in, you can see these sorts of things. So as you'd expect down the bottom, we've got an awful lot of expertise about Windows Desktop, because pretty much everybody knows, I say pretty much, 68 people know about that. And then at the other end, you find there's a whole bunch of things around, sadly, exactly the sorts of things you need to know about for doing large data. I'll say large data rather than big data. Data science, that kind of work, which is something which is definitely a growth within the sector at the moment, across all subjects: arts and humanities, sciences, engineering. So we use this information to pick out some single points of failure within our organisation, but mainly we used it to identify things that we were really short of. The fact that a little bit of expertise and knowledge of this expertise can make a big difference is illustrated by this really nice chance example that came shortly after doing this survey. So we needed somebody, a researcher came to us with a whole load of Ebola blood data. So they were getting the data, it's coming into Liverpool, and then transferred using the file transfer thing that we'd set up earlier, down to Bristol to do the analysis. And it happens in something called Galaxy, which is a workflow engine that bioinformaticians use. We don't have much expertise on that sort of thing within IT services, and in fact, there's questions about whether IT should know about that sort of thing. But we had one person who knew a bit about it, and by bringing this person together with the academic over the course of a weekend, he just volunteered his time because of the cause and everything. This is not an established process yet. This is somebody applying goodwill, but it was enabled by knowing we had these skills. He was able to join together two processes, quite a simple thing for him to do, and the academics were so appreciative, they actually added him to the list of authors in the Nature paper. So it's a long list of authors, and they might possibly have spelled his surname wrong. But once in a life, you get a Nature paper and they get your surname wrong. Yeah, yeah, hard luck, Damien. But they actually put out a press release, and they made a specific reference to IT within that, research IT and advanced computing. So that sort of thing doesn't happen often. So in terms of public relations with our client base, as it were, This whole research, supporting research thing, quite small amounts of effort can produce fantastic results. But this is only enabled because we'd actually looked in some detail at what skills we actually had. And we do find that we're going to have to beef up the amount, or meatloaf up, whatever it is, for the vegetarians, the amount of expertise we have in that space, and that's one of the big sort of things we're concentrating on at the moment. Just when you think things are starting to get sorted out, so we're getting a handle on the big data thing a little bit, along comes the next sort of thing out of the wings, and this is that software needs to be cited too. So this is really hard. This is really hard. Not only does it need to be cited, I mean, the funders have kind of let this one go for the moment, but they're starting to make noises about, well, actually, you're going to need to make the software available as well. It makes for good reproducible science. You know, intuitively, it's a good thing. It's just hard. It's just very hard. And sticking stuff on GitHub, that's fine. That helps. Virtual machines help. But yeah, what about licensing, dependencies, security, skills, all those other things? So this is one of the things that we're now starting to sort of talk about. We don't have any solutions around this yet, although we have already taken deposit of a couple of VMs. Docker is an interesting technology in this space. Some great work going on at the Software Sustainability Institute. Definitely take a look at their offerings. Okay, and the other thing that's come out of the wings is growth in collaboration. So this, you know, we're in Scotland at the moment. There's going to be the equivalents here, these local regional networks, where I'm being filmed. Where vice chancellors will perhaps go out to dinner and decide that they should form a network and share stuff, and then it sort of comes down that, yeah, we need to set up these regional collaborations. And so there's some meeting of the bottom-up activities within the organisation, the top-down pressures. Similar sort of thing with World Universities Network. The partnering and sharing of resources is one of the areas that we're looking at the moment. And then there's some very interesting stuff going on around mediated collaborations, particularly around sharing sensitive data. There's some great stuff going on in the Data Shield Foundation, where essentially they're taking algorithms to data. So you don't release your medical records, the algorithm goes to the database and runs there. So this particular one's a sort of stripped down version of R. Very, very interesting stuff. And I told you I always include adverts for Bristol Online Service, because we're increasingly using this for research benchmarking now. So comparative work. And finally, I was asked to sort of say something about REF 2020. Well, actually, yesterday I learned it's REF 2021, so it's already a year out of date. But this turned out to be one of the hardest things to find out about overall. We're already into the submission period, so you've got to be second guessing. There was a little bit of information in the green paper that we heard quite a bit about yesterday. My best guess on this, and this is my last slide, my best guess on this is that data publication, research data management practice will be seen as a good thing, and those institutions that rank highly on research in the REF will be doing that. But in and of itself, I think it's too early. I don't think REF 2021 is going to be the one where you actually start getting any significant amount of credit for this. I might be wrong. I'd love to be proved wrong, but I suspect not this time. But maybe the time after, the long-awaited reward for actually doing this sort of thing properly will start coming through. So I'll stop there and open up for, I don't know if...
Time for a couple of quick questions.
Shocked and stunned. Yep.